Hello Primary 5, how are you today? I hope you are fine. Today we are going to complete our lesson, operations on large number, and today we are going to start with the multiplication operation. But before we start, we have to remember that the set of natural numbers is denoted by n equals 0, 1, 2, 3, and so on, because the set of natural numbers is an infinite set. And we had started that how to represent the set of natural numbers on a numbers line. So we have to use this line segment to represent the set of natural numbers, and we have a start point and no end point, because the set of natural numbers starts from 0 and no end point. So let's represent the numbers and the set of natural numbers. We have to start with 0, then we keep this distance and put 1, then 2, 3, 4, and notice that the distance between every two numbers should be equal. So we have 4 and 5, 6, 7, 8, 9, and so on. So we use this arrow to represent that we have an infinite numbers in the set of natural numbers. And now we need to represent the multiplication operation on number line. And we had started before this, the multiplication is a revision of addition, the revision of addition. So for example, if we have 2 times 3, 2 times 3, so we have to skip count by 2 for 3 times. So we have 2 and 2 and 2, so we can say 2, 4, 6. So we have to skip count by 2. So we have 2 times 3, and we need to represent this operation on the number line. So we have to skip count by 2. We start from 0, then we have 2, 4, 6. So we skip count by 2. Skip count by 2. So we have 6. 2 times 3 equals 6. And we had started before, there is a property called the commutative property. So let's check the commutative property and the natural numbers. We have 3 times 2. Okay, 2 times 3 equals 3 times 2. So let's represent this operation on the numbers line. We have to skip count by 3 because we have 3 times 2. So we have 3 and 3. So 3, 6. Or we skip count by 3. So we have 3, 6. So we skip count by 3. So we have 1, 2. So this is the skip counting by 3. So 3 times 2 equals 6. So the commutative property is possible in natural numbers. And we notice that the product of any two natural numbers is also a natural number. So if we multiply any two natural numbers, the product will be a natural number. So 6 belongs to n. And if you multiply 3 times 2, 6 is also belongs to n. And we had started that this property is called the closure property. The closure property of multiplication and the set of natural numbers. So we have the commutative property and the closure property. And now let's check if we can use the associative property in multiplication and the natural number. For example, if we have 2 times 3 times 4 and 2 times 3 times 4. But in the first term, we have to multiply 2 times 3, then we multiply by 4. And in the second term, we have to say 3 times 4, then we multiply by 2. We have in the first term, 2 times 3 equals 6 times 4. So 6 times 4 equals 24. So this is equal 2 times 3 times 4, but now we have to start by multiplying 3 times 4. So we have 2 times 12. 2 times 12, and 2 times 12 is also equal 24. So the associative property is possible in the set of natural number, or in the multiplication operation in the set of natural numbers. So the associative property is possible in multiplication operation in the set of natural numbers. And we had started before that if we multiply any number by 1, so the product will be the same number. For example, if we have 5 times 1 equals 5, and 6 times 1 also equals 6. So if you multiply any number by 1, so the product will be the same number. And we have studied that if we multiply any number by 0, so the product will be 0. So 5 times 0 equals 0, and 6 times 0 equals 0. So we have 6 times 0 equals 0. So we have two properties. The first one is the natural multiplicative. The natural multiplicative is 1, because if we multiply any number by 1, so the product will be the same number. The product will be the same number. And the second property is 5 times 0 or 6 times 0 or any number multiplied by 0 equals 0. So these are two properties. These are two properties. And the last property is the distributive property, and we had studied it before. For example, if we have 5 times 13, so we have to say, or we can say that we have 5 times. For example, 5 times 10 plus 5 times 3. So we have 5 times 10 plus 5 times 3. So we have 5 times 10 equals 50. So we have 50 plus 5 times 3 equals 15. So 50 plus 15 equals 65. So the distributive property is also possible in the set of natural numbers. So now let's start with the division operation. If we need to divide two natural numbers, if you want to divide any two natural numbers, sometimes it is possible and sometimes it is not possible in the set of natural numbers. For example, if we have 6 divide 2, 6 divide 2 equals 3. And 3 belongs to the set of natural numbers. So this operation or this division operation is possible in the set of natural numbers. And if we have 2 divide 6, 2 divide 6, so 2 divide 6 equals 2 over 6. So 2 divided by 6 equals 1 over 3. And this fraction doesn't belong to the set of natural numbers. So this operation is not possible in the set of natural numbers. So sometimes the division operation is possible in the set of natural numbers and sometimes not possible in the set of natural numbers. And now let's start by solving some exercises in our book. We have in the first question 3 natural numbers a, b, and c, where a equals 12, b equals 4, and c equals 2. And the letter a, is a divide b equal to b divide a or not? So a divide b equals, so we have to find a divide b. So a divide b equals, a equals 12, divide b equals 4. So we have 12 divide 4 equals 3. So 12 divide 4 equals 3. And if we need to find b divide a, so we have 4 divide 12. So 4 divide 12 equals 4 over 12, and 4 over 12 equals 1 over 3. So a divide b not equal to b divide a. So the answer of the first question is no. And the second question, letter B, is a divide b equals c, and c belongs to n. Yes, c belongs to n, because we find a divide b equals 3, and 3 belongs to n. So the answer of letter B is yes. And now, letter C, is a divide b divide c equals a divide b divide c? Let's check that. We have a divide b equals 3, divide c. So we have a divide b divided by c, so c equals 2, so we have 3 divide 2 equals 3 divide 2 or 3 over 2. And we have here a divide b divide c, so we have a equals 12 divided by b divide c, b equals 4 divide 2, so 4 divide 2 equals 2, and 12 divided by 2 equals 6. So they are not equal, so no. And in letter D is C times A divided B equals C times A divided C times B. We know that A divided B equals 3, so C equals 2 times 3 equals 6, and the second term equals C times A, C times A. So we have to say C times A. A equals 12 and C equals 2, so we have C times A equals 2 times 12 divided by C times B. So we have C equals 2 and B equals 4. So we have 2 times 12 equals 24 and 2 times 4 equals 8. So we have 24 divided 8 equals 3, and we have 6 and 3, and they are not equal, so no. And now let's start with these exercises. We have in this question, and question number 1, complete until the property used. And letter A, we have 4 times 31 times 25, and we notice that 4 times 25 equals 100, so we have to say 4 times, or we have to start by multiplying 4 by 25. So we have to use the commutative property, so we have 31 times 4 times 25. Then we use the associative property, so we have to say 4 times 25 equals 100, and if we need to multiply any number by 100, so we add just 2 zeros, so we have 31 and we add 2 zeros, so we have 3100. And in letter B, we have 2 times 13 times 5, and we notice that 2 times 5 equals 10, and when we multiply any number by 10 or 100 or 1000, that will help us to make the operation be more easier. So 2 times 13 times 5, so we have to multiply 2 by 5. So we have to use the commutative property to replace the 13 by 5 to be 5 times 13, 5 times 13, and we have to say using the associative property, we have 2 times 5 times 13, so 2 times 5 equals 10, and 10 times 13, we write 13 and we add 0, so we have 130. And in letter C, we have 7 times 98 plus 3. We have to use the distributive property, but we can't change these two numbers. We have 98 plus 3. 98 plus 3 equals 101. So we can change these two numbers to help us to find the product. So we can say we have 7 times 100 plus 1. So we have 7 times 100, 7 times 100 plus 7 times 1, 7 times 1, and this is called the distributive property. And using the distributive property, we have 7 times 100 equals 700 plus 7 times 1 equals 1, so 700 plus 7 equals 707, and we can say this is the closure property of multiplying and the set of natural numbers. Let's look at the second question. We have use belongs or doesn't belong. In letter A, we have 0 over 7 and the set of natural numbers. So 0 over 7, we had studied before that if we need to divide 0 by any number expect 0, the quotient will be 0. 0 divide any number expect 0, so the quotient will be 0. So 0 divided 7 equals 0, and 0 belongs to the set of natural numbers. Okay, so 0 over 7 belongs to the set of natural numbers. And in letter B, we have 8 minus 8. 8 minus 8 equals 0, and 0 belongs to the set of natural numbers. And in letter C, we have 3 over 2 minus 2. 3 over 2 minus 2. So we have 3 over 0. And we can't divide any number by 0. We can't divide any number by 0. So 3 over 2 minus 2 doesn't belong to the set of natural numbers. And in letter D, we have 7 times 3. 7 times 3 minus 3 times 7. 3 times 7 equals 7 times 3. Why? Because we have a property called the commutative property in multiplication. That means that we have the same numbers. So 7 times 3 equals 21 and 3 times 7 equals 21. So 21 minus 21 equals 0, and 0 belongs to the set of natural numbers. And in letter D, we have 7 times 2 minus 7 times 5. Okay, 7 times 2 equals 14 minus 7 times 5 equals 35. This operation is not possible in the set of natural numbers because we had studied if we need to subtract two numbers, for example, A and B, and if we need to say A minus B, so A should be more than or equal B, and now we have A is less than B, so this operation doesn't belong to the set of natural numbers. And in letter F, 0 times any number equals 0. 0 times 9 equals 0, so 0 belongs to the set of natural numbers. Let's look at the third question. In the third question, we have complete to get a true sentence. The additive natural element in n is 0, where the multiplicative natural element in n is. So there's a difference between the additive natural and the multiplicative natural. So additive natural is not equal the multiplicative natural. Okay, and the multiplicative natural element in n is 1, because 0 change nothing in the addition and 1 change nothing in the multiplication. And letter B, we have if 9 times 13 equals 13 times x, then x equals, using the commutative property, we notice that 9 times 13 just equal 13 times 9, so x equals 9. And in letter C, we have 93 plus 87 minus 87 plus 93, and we had studied that the addition operation is a commutative in the set of natural number. So we have 93 plus 87 equals 87 plus 93, and if we subtract any number from itself, so the difference will be 0. The difference will be 0. And in letter D, we have 7 times 0. 0 times any number equals 0 divide any number, expect 0, equals 0. And in letter E, the opposite figure, if m and n are two natural numbers, m and n are two natural numbers, then which one is the greatest? We have studied before, if the point n placed to the right of m, so n is the greatest, because when we move to the right, we get a greatest numbers, so m is less than n. m is less than n. And let's look at number 4. We have a number 4, complete using odd, even, prime, neither. Okay, complete using odd, even, prime, neither. So in letter A, we have an odd number plus an even number equals odd numbers. Equals odd numbers. Why? Let's check that. If we have, for example, even number like 2 plus any odd number like 1, so 2 plus 1 equals 3, and 3 is odd numbers. And in letter B, the sum of two odd numbers equals. Okay, let's check using any two odd numbers. For example, if we say 3 plus 5, so we have to say 3 plus 5 equals 8. 3 is odd number and 5 is odd number and 8 is even numbers. So the sum of any two odd numbers will be even numbers. Will be even number. Okay, and letter C, an odd number times an even number equals. So let's check by the same way. If we have, for example, 5 times 4, 5 is odd number and 4 is an even number. So let's try to find the product. 5 times 4 equals 20 and 20 is even numbers, so the product of an odd number and even number will be even number, And letter D, if x is an odd number, then x plus 2 is an odd or even number. We had studied before that if we need to write or if we need to sort the elements in the set of odd numbers, so we have to start by 1, then we skip count by 2. So when we add 2, that will be the same. So that will be odd number. And if we need to sort the elements and the set of even numbers, so we skip count by 2, but we start from 0. So let's look at letter E. If x is an odd number, then x minus 1 is. Okay, the difference between any two odd numbers or any two even numbers is 2. But if the difference is 1, so they will be changed from an odd number to be an even number. So if x is an odd number, then x minus 1 is even number. And letter F, the smallest prime number times any prime number. We had studied before that the smallest prime number is 2. And if we multiply 2 by any number, the product will be a multiple of 2. And if the product is a multiple of 2, so it will be divisible by 2. And all even numbers are divisible by 2. The even numbers divisible by 2, so the smallest prime number 2 times any prime number. 2 times any number is equal a number that is divisible by 2, so any number divisible by 2 is an even number, so even number. Okay, and now let's look at the question number 5. We have tell whether each statement is true or false. Tell whether each statement is true or false. Letter A, we have 81 plus 112 times 117 equals 117 times 112 plus 81. So letter A, we use the commutative property in addition because we replace 81 by 112 and 81 by 112, so they are equal. Okay, so this is true. Okay, and letter B, we have 5 minus 8 belongs to n. No, this is false, and the whether is if we need to subtract any two natural numbers like a and b, so a should be more than or equal b. So this statement is false. And in letter C, we have 28 divide 6 belongs to the set of natural numbers. Let's check this. We have 28 divide 6. And 28 divide 6 equals, we can divide by 2, or we can divide the two terms by 2 because they are divisible by 2. We have 28 divide 2 equals 14, and 6 divide 2 equals 3, and 14 divide 3 equals 4 and 2 over 3. So we have a fraction or a mixed number, and the fractions and the mixed numbers doesn't belong to the set of natural numbers, so this statement is false. And in letter D, we have 5 minus 0 equals 0 minus 5. No, this is false because there is no commutative in subtraction. No commutative in the subtraction, because we had studied that if we need to subtract a minus b, so a should be more than or equal b. So this is a false statement. And on letter E, 120 plus 80 times 4 equals 120 times 4 plus 80 times 4. Yes, this is true because we use the distributive property. We say 4 times 80 plus 4 times 120. 4 times 120 plus 4 times 80. So we have the same answer. So this is a true statement. And now let's look at the question number 6. In question number 6, we have calculate using commutative and associative and distributive properties, and check your answer using a calculator. Letter A, we have 2 times 347 times 5. So we have 2 times 347 times 5. So we can say 2 times 5. So we can say that we can use the associative property to multiply 2 by 5. So we will be able to multiply by 10. And when we multiply by 10, we just add 0. So 2 times 5 equals 10. 10 times 347 equals 3,470. 3,470. And that helps us to make the operation more easier. So let's look at letter B. We have 4 times 128 times 75. So we have 4 times 128 times 75. Okay, we can say using the commutative property, so we can replace these two terms. So we have 4 times 75 times 128. Okay, we notice that 4 times 25 equals 100. So we can use the distributive property to find the hundreds. So we have 4 times 75 equals 50 plus 25 times 128. So 4 times 50 equals 200 plus 4 times 25 equals 100 times 128. 128. 200 plus 100 equals 300. 300. So we have 300 times 128. Now I think this is more easier than before. So we have to put 2 zeros, then we multiply 3 by all digits. So we have 2 zeros with 0 and 0, and 3 times 8 equals 24. So we put 4 and carry up 2, and 3 times 2 equals 6 plus 2 equals 8, and 3 times 1 equals 3. So we have 38,400. Let's look at letter C. And letter C we have 8 times 49 times 125. So we have to say 8 times 125 equals 1000. Equals 1000. 8 times 125 equals 1000. We have 8 times 49 times 125. So we have 8 times 49 times 125, and we notice that 8 times 125 equals 1000. So using the commutative property, we have to say 8 times 125 times 49. Then we use the associative property to say 8 times 125 equals 1000 times 49. So we have to put 3 zeros, then 1 times 49 equals 49. So we have to put 3 zeros, then 49. So we have 49,000. And in letter D, we have 10 times 75 plus 812 plus 25. So in letter D, we have 10 times 75 plus 812 plus 25. And we notice that 75 plus 25 equals 100. So we can say that's equal 10 times 75 plus 25 plus 812, and this is the commutative property in the addition. And using the associative property in the addition, we have to say 100. We have 75 plus 25 equals 100. So we have 10 times 100 plus 812. And now this is very easy because we have 10 times 100 plus 812. So we have 10 times 100 plus 812 equals 912. So we have to put 10. So we have 9,112. 20. 9,120. Now let's look at letter E. We have 125 times 8, that's equal 1000, plus 25 times 40, so we put 0, then we multiply 4 by 25 equals 1000, so we have 1000 plus 1000 all times 90, so we have 2000 times 90, so we can say 2000 times 90, so we have to put the zeros, we have 1, 2, 3, 4 zeros, so we put 4 zeros, 1, 2, 3, 4, then we multiply 9 by 2, we have 18, so we have 180,000, 180,000. And in number 7, if A equals 3, B equals 4, and C equals 0, find the value of the following. Okay, in letter A, we have 2 times A plus 5 times B. 2 times A, that's mean 2 times 3. 2 times 3 plus 5 times B. B equals 4, so we have 5 times 4. So we have 6 plus 20. So we have 6 plus 20 because 2 times 3 equals 6 and 5 times 4 equals 20. So we have 6 plus 20 equals 26. I think this is very easy, right? So let's look at letter B. We have A times C plus B times C. So A times C, A equals 3. So we have 3 times C equals 0. So 3 times 0, we have 3 times 0 plus B times C, B equals 4. So we have 4 times 0. So 3 times 0 and any number times 0 equals 0 plus 4 times 0 equals 0 and 0 plus 0 equals 0, and this is very easy. Okay, and letter C, we have 3 times A plus 5 times B all times C. So we have 3 times A, so 3 times 3 because A equals 3, so we have 3 times 3 plus 5 times B. 5 times B equals 5 times 4 because B equals 4, so we have 5 times 4 all times C, so all times 0, and anything multiplied by 0 equals 0. Okay, and in letter D, we have A plus B minus C times A plus B. So we have to replace A by 3, so we have 3 plus B, B equals 4, minus C, so minus 0 because C equals 0, and times A plus B, times A plus B. A equals 3 and B equals 4, so 3 plus 4. And 3 plus 4 equals 7, so 7 times 7, so we have 7 times 7 equals 49. 7 times 7 equals 49. And in letter E, we have B minus A times B plus A, and we notice that B equals 4, so we have to replace it by 4, and A equals 3, so we replace it by 3, so 4 minus 3 times 4 plus 3. Okay, so we have 4 minus 3 equals 1, and 4 plus 3 equals 7, so we have 1 times 7 equals 7. And now let's look at the question number 8. And the question number 8, let x be an even number between 2 and 3 and 8. Find the values of x, then represent the values of x over 2 on a number line. So we have to find the values of x, then we represent the values of x over 2 on number line. We notice that x is an even number between 3 and 8, between 3 and 8. So this number will be 4 or 6. So these two numbers will be 4 or 6. So we have the value of x. So x equals 4 or x equals 6. And we need to represent the values of x over 2 on the numbers line. So we have to draw this number line. Then we put our values. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, and so on. So now we need to represent the values of x over 2 on this number line. So x equals 4, so x over 2 equals 4 over 2 equals 4 over 2 equals 2. So the value of x over 2 may be 2, or x equals 6, so x over 2 equals 6 over 2 equals 3, so may we have 2 or 3. So the values of x is 2 or 3. Let's look at the next question. Write the results of the given expressions in an ascending order. Ascending order means from the smallest to the greatest, and we need to write the results of the following, or of the given expressions, in an ascending order. In the first expression, we have 7 times 10 equals 70, so we have 70. Then we have 35 minus 0 equals 35, and 178 minus 178 equals 0, and 2 times 3 all times 5, so 2 times 3 equals 6, 6 times 5 equals 30. So we have to write the results of the given expressions in an ascending order, and these are the results. So we have 0, then 30, and 35, and 70. So this is the order. And in the question number 10, complete the patterns. In letter A, we have 8, 11, 14. So we have to find the rule of this pattern. So we have to say 11 minus 8, 11 minus 8 equals 11 minus 8 equals 3. And we have to say 14 minus 11, 14 minus 11, and 14 minus 11 equals 3. So when we move to the right, we add 3. We add 3. So the rule of this pattern is plus 3. So when we get back, or when we move to the left, we have to take 3. So we have 8 minus 3 equals 5, and 5 minus 3 equals 2. And when we move to the right, we add 3. So 14 plus 3 equals 17, and 17 plus 3 equals 20. And in letter B, we have 12, 24, 48. So when we move to the right, we multiply by 2. So we have to multiply by 2. Then when we move to the left, we have to divide by 2. 12 divide 2 equals 6, and 6 divide 2 equals 3. And 48 times 2, so we have to say 2 times 8 equals 16. We put 6 and carry up 1, and 2 times 4 equal 8 plus 1 equal 9. Then we have to multiply by 2. So 2 times 6 equals 12. So we put 2 and carry up 1, and 2 times 9 equals 18 plus 1 equals 19. So we have 192. Now we finished our lesson. So you have to study hard and stay safe. Good luck.